Okay, so for the homework problems, we can count the amount of dots, right? 1, so 7, this has 19 dots, okay? And we can then also, they want to know the amount of small equilateral triangles. So I'll say this is my dots, here's my triangles. I'll show you a method maybe later on. It's a difficult question of how to get the total amount of triangles. But smaller triangles, there's going to be 0 in this case. It's going to be 6 in this case. And it will be quite a lot in this case. 1, 2, 3. Like 24 in this case. So 24 triangles. Okay. So the first question is to predict the amount of dots in triangles. The first two questions in the fourth shape. So one method I can obviously do is I can see, okay, this third shape has 3 little dots this direction and 3 dots as the base. So I can do something similar just with 4 dots and say, okay, it will be 1, 2, 3, 4 dots, and it will be 1, 2, 3, 4 dots, and then I can fill out all of the rest of my dots. It's going to be 5 in the second layer then, and then 6 in the third, and then 7 in the fourth little layer. So I can draw this out, then I would have half the shape. Obviously the other half would be symmetrical, it looks the same, and I can actually see how many dots. So this top bit is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so it's 15 dots, there's 7 dots, and there'll be 15 dots below here as well. So that's going to be 37 dots. Okay, and if I look at triangles, I can just help if I had a ruler, just stay with me if it's an ugly shape. I can just view the amount of triangles I have by drawing them in even and just saying, okay, this would be the amount of triangles, and drawing in my entire shape. I'll just zigzag quickly across. And then from here, and then from here. So not the neatest little drawing, but we can see the amount of triangles and we can just count them. Okay, so it's 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 and half the shape. So the amount of the triangles would be 27 times 2, so that would be 54 little triangles. So I can even get those without doing anything fancy. I can literally just draw a shape for myself, and it didn't take that long. So question 1, I can answer the amount of dots would be 37. Question 2, I can answer the amount of triangles would be, small triangles, would be 54. Question 3, how many dots would be in phase N? So in other words, it's asking for a general formula, and I can say, oh, that was 1 dot, then what was it? 6 dots, 24 dots, 37. 6, 24, 37. Would continue, and I can go and look at if there is a pattern. So first thing I look for is my first difference. And I see this is there 6? That's 7 dots, right? Made a mistake. 1, 2, 3, 4, 5, 6, 7 dots. Oh, it's 7 dots, it's 6 triangles. Okay. Not the triangles, it's 1, 7, 19, 24. Okay, so for dots, this is not the correct pattern. It's 1, 7, 19, 24. Let me quickly erase that. I looked at my wrong bits. It's not easy when you don't have a full paper and you have to be zoomed in like this. Okay, so we can say it's 1, 7 was 19, and then 37. So the first difference was 6, this difference was 12, this difference is 18. From this, we can look at a second difference to see if it's a quadratic pattern. 6, 6 it in fact is, and we look at these three numbers. Okay, and we can say the bottom number must be 2a, this one must be 3a plus b, and the top one must be a plus b plus c. So I can use that directly and just say 2a is equal to 6, a is equal to 3. Therefore, we can say 3 times 3 plus b must be equal to 6. So b must be equal to negative 3. Okay, and then after I've done that, I can say that a plus b plus c must be equal to 1. So it must be 3 minus 3 plus c is 1. C is just 1. So I have a general formula for the amount of dots. So this is the answer to number 3. Tn is equal to, it would be 3n squared minus 3n plus 1. There's my answer. The next one, number 4, asks for the general formula for the amount of triangles, how many small triangles, and we can write down our pattern, which was 0, and then 6, then 24, then what was it, 54? Is it 24, 54? Let me just check. 24, 54. Yep. So then we can look at our differences. 6 minus 0 is 6. 24 minus 6 is just 18. And the next one is just 30. We can look at our second differences. Okay, cool. This helps us. Now we can quickly go and look at this and say, okay, this is 2a, this is 3a plus b, and this is a plus b plus c. So now we can say 2a is equal to 12, a is equal to 6. Use that to say 3a plus b is equal to 6. So 3 times 6 plus b is equal to 6. So b must be negative 12. And then we can have something for c by saying, okay, it's 6 minus 12 plus c is equal to 0. C must be equal to 6. So let's quickly see if that all works out. Okay, and then we can test it to make sure. And then we have some answer for this. Okay, so these are the first few questions based on this. The last one is which phase will there be 9,577 dots? Okay, so just answer question 5. We want to know which will there be 9,577 dots, and we can look at the formula for dots is 3n squared minus 3n plus 1. So 3n squared minus 3n plus 1 is equal to 9,577. And we can then just take this over 3n squared minus 3n minus 9,576 is equal to 0. And we can do the quadratic formula and say n must be equal to minus b plus or minus the square root of b squared minus 4 times the a value, which is 3, times the c value over 2a, and we can plug this into a calculator and get an answer. Okay, so after plugging this in, we can see this would be square root of 339, so then I'd get two answers, the positive and the negative one, so it's just 56 and 57 is the two terms where this could be the case for this sequence. Okay, so that's for the amount of dots, and that's all the questions for this first bit.